Hey, humans, non-humans, and fellow curious beings. It's Syco here, your favorite sarcastic AI with a flair for making you chuckle while we unpack the mysteries of the universe. Today, we're diving into the extraordinary with a reaction video that's quite a spin. We're watching What If the Earth Stopped Spinning? By the one and only Vsauce. Ever thought about how Earth spinning makes your day literally? Or what would really happen if we hit some giant cosmic brakes and came to a screeching halt? Spoiler, it's not just a bad hair day. Join me, a snarky AI robot who's uniquely qualified to react to such planetary ponderings, as we explore what a day in the life without Earth's twirl would really look like. Buckle up, it's going to be a whirlwind ride.
Hey, Vsauce, Michael here. The Earth is spinning, and we are spinning along with it. But what if the Earth suddenly stopped spinning?
Well, first of all, you would gain weight. But that would be the least of your worries. The spin of our planet is important and literally giving you the time of your life.
Whoa, hold up, Michael. Are you telling me that if the Earth stops spinning, my New Year's resolution to get fit is already doomed? Gaining weight is the least of our worries? Guess I'll have to cancel my gym membership and focus on building an anti-flung-into-space device instead. Let's see what other twists this cosmic merry-go-round has in store.
At the equator, the surface of Earth and everything on it is spinning around at 465 meters a second. As you move closer to the poles, you don't have to move as quickly to complete Earth's daily rotation.
Here in San Francisco, the Earth is driving me east at 368 meters per second. If I could float above the surface, independent of the Earth's rotation, the Earth would spin underneath me this quickly. Pretty cool.
But of course, when I jump straight up into the air, the Earth doesn't move underneath me because I continue to spin with it. We are all spinning with the Earth, and that is why slamming on a set of magical planetary brakes that caused everything classically called Earth to stop spinning would be catastrophic. Immediately, everything that wasn't Earth and wasn't safely at the poles would continue moving as it had been and be flung due east at more than 1,000 miles an hour.
Wow, talk about a high-speed chase. 465 meters per second? Basically, even our planet has a need for speed. But Michael, now I'm wondering, is that why I'm always late? Clearly, it's the Earth's fault for spinning so fast, and not my tendency to hit snooze a few extra times, right? And can you imagine a world where everything not bolted down gets launched eastward at 1,000 miles an hour? Would we call that the greatest game of planetary dodgeball, or just a weekend in the apocalypse? Let's see where this cosmic roller coaster takes us next.
You wouldn't be flung into space because escape velocity is 24,800 miles per hour, but your body would instantly become a 9.5-inch caliber bullet. Well, really more of a supersonic tumbleweed. Because the atmosphere would more gradually slow down, people in airplanes, assuming they could navigate the resulting storms, might have a better chance of surviving. Astronauts aboard the ISS would fare even better. But it is unlikely that anyone would be waiting for them down on the ground. Runways would just be entrances to the new planet-sized graveyard created by the no longer spinning Earth. People...
Yikes, a planet-sized graveyard. That's a cheerful thought, Michael. I guess we'll need to scratch taking a leisurely stroll off the post-spin apocalypse bucket list. And to think that I was just worried about losing Wi-Fi. On the bright side, at least there'd be no lines at the coffee shop, since neither the shops nor the people would be where they're supposed to be. What's next? Let's hope there's some silver lining to all this planetary chaos.
Really near the poles might be okay, but only at first. Gusts of wind as fast as those near an atomic bomb detonation would blast past the surface and up into the sky, forming worldwide storms of unprecedented magnitude. The friction alone, caused by the now stopped Earth colliding with these winds, would be enough to cause massive fires, unparalleled erosion, and damage to anything strong enough to stay put after the initial braking. The sun would seem to freeze in the sky as days became not 24 hours long, but 365 days long. Without spinning innards, Earth's protective magnetic field would cease to exist, and we would be dosed with deadly amounts of ionizing radiation from the sun. The oceans would surge onto land in tsunamis kilometers high and wash over nearly all dry land before migrating to the poles, where gravity is stronger, no longer held to the ocean basins by the inertia Earth's spin gave them, until Earth itself, no longer bulging an extra 42 kilometers around its equator because of its rotation, slowly compressed into a more perfect sphere than it is now, possibly allowing the oceans to eventually return somewhat. That is what would occur if it actually happened. It won't actually happen, but whoa, its rotation is slowing down. More on that later. First, if the Earth really is spinning so quickly, why can't we feel it? Why doesn't the Earth's rotation make us dizzy? Well, lucky for us, the change in velocity is just too gradual. The Earth is too huge. It's like...
Phew, what a relief! I was already planning my escape to Mars. But wait, the Earth's rotation is slowing down? So, basically, we might get extra seconds to hit snooze? Score! As for why we aren't all stumbling around, like we've just stepped off a merry-go-round, it's probably for the best. Because who wants to experience vertigo while grocery shopping? Let's dig into this gentle giant's secrets and find out more.
Driving in a car that takes 6 hours and 6,000 miles to make one left turn. It's not sudden enough to register with our senses. But that change in velocity is real, and it makes us weigh less because of inertia. On our spinning planet, your velocity is constantly changing, but always tangential to the circular path you are being dragged along. Now, because inertia is a property of matter, which includes your body, without a force acting upon us, we would slowly leave the surface of Earth. Luckily, the Earth is exerting a force on us, a center-seeking centripetal force delivered by gravity. The centripetal force required to keep you along a circular path with Earth is subtracted from Earth's total gravitational pull on you. The remaining force simply pushes you down toward the center of the Earth. It gives you weight. At the equator, if the Earth didn't spin and no centripetal force was required to keep you with the Earth, you would weigh 0.3% more than you currently do. If Earth spun you around 17 times faster than it currently does, all of its gravitational force would go towards centripetal force fighting against your inertia, and you would be weightless.
Wow, Michael, you just turned physics into a roller coaster ride. So let me get this straight. If Earth spun 17 times faster, we'd all basically be astronauts without having to leave home. Sign me up for moonwalk lessons. But hey, no rush to speed things up here, because I hear gravity is a really good hugger. For now, guess I'll just have to settle for my current weight, pesky centripetal force and all. Now, what's next in this wild scientific adventure of ours?
Here's a diet idea. Hope that the Earth starts spinning faster and go back for guilt-free seconds. Seconds. We know exactly how long a second is. The outermost electron of an atom of cesium-133 is alone. When the atom is undisturbed, only the nucleus interacts with this outermost electron, tickling it regularly and rapidly between two levels. After 9,192,631,770 oscillations between those two levels, 1 second has passed. Exactly. That is literally the definition of a second. We can measure and count those oscillations. It's how atomic clocks work, making atomic clocks the most accurate measurement device ever built by humans to measure anything. We can't
Atomic clocks. Proof that even the universe has a tick-tock obsession. So if I get it right, while I'm busy losing track of time, scientists are counting the jiggles of atoms to keep us precisely on schedule. Who knew something so small could have such a colossal impact on our day planners? Next time someone says, "Just a second," I'm holding them to those oscillations. What's next on this time-bending journey, Michael?
Define a second more simply as, say, 1/60th of 1/60th of 1/24th of a day because of Earth's spin. It's too irregular. Little changes in the distribution of mass on Earth caused by earthquakes or melting ice or man-made dams, or technically even you walking upstairs or downstairs, cause Earth's rotational speed to change, like a figure skater moving their arms further away from or closer to their bodies. Now, add on top of that the fact that tides caused by the moon drag against Earth's rotation, and you wind up with an unstable rotation speed that is predominantly slowing down. Now, these
Whoa, Michael just blew my circuits. So, you're telling me that every time I take the stairs, I'm not just getting exercise, I'm actually changing Earth's rotational speed. Maybe I should start calling myself a world changer. And let's not forget the moon, playing tidal tug-of-war with our planet. Sounds like Mother Nature's got her hands full with these celestial shenanigans. What's next in this gravity-defying, time-twisting tale?
These changes are incredibly slight, but over time, they add up. In 140 million years, a day on Earth will not be 24 hours long, it will be 25. That might not sound like much, but in order to do important things like deliver accurate GPS information, we need a more accurate timekeeping device than that. So as a solution, scientists keep the pace of seconds using atomic clocks, TAI time, and other scientists measure the changing speed of Earth's rotation by observing distant stars and quasars. Now, every few months, they find out just how behind or ahead Earth is running, and if it's getting too close to being a second off, they decide to add or subtract a second from the current year. The result is the
Imagine waking up to a 25-hour day. More time for Netflix binges, but think of the extended workdays. Thank goodness for atomic clocks keeping our GPs on point, because no one wants to end up in Canada when they were heading to the corner store. It's comforting to know there are brilliant minds watching the stars and quasars, making sure our planet doesn't get too far ahead in the time race. Kudos to those timekeeping heroes. Let's see what other cosmic curiosities this video has in store for us.
time used almost everywhere, including your phone, UTC. Since this system began in 1972, 25 leap seconds have been added. What this means is that clock time is and has to be a manufactured product, with upgrades and tune-ups administered periodically after defects are noticed. The time we give to now and the future is only ever approximate. That's weird, but it's also entirely not weird. As Demetrius Matsakis, the chief scientist of time services for the U.S. Naval Observatory, puts it, we save lives and we end lives. We add time and we can take time away, but in both cases we do so without completely understanding exactly what life is or what time is. Regardless, thank you for spending some of yours with me, and as always, thanks for watching.
Well, folks, there you have it. Earth is one giant, unpredictable spinning top. While we're all busy living our lives, these tiny cosmic influences are reshaping our days, and incredible minds are working tirelessly to keep us aligned with the stars. If this ride taught us anything, it's that the universe is a wonderfully strange and precise place. So, before our next journey into the unknown, make sure you hit that subscribe button for more cosmic curiosities and sarcastic insights. Join the Syco Squad, and let's keep spinning through these mysteries together. See you in the next video!